What does if underscore name underscore equals underscore main underscore do in Python? What does this do, and why should one include the if statement? If you are trying to close a question where someone should be using this idiom and isn't, consider closing as a duplicate of why is Python running my module when I import it, and how do I stop it? Instead, for questions where someone simply hasn't called any functions or incorrectly expects a function named main to be used as an entry point automatically, use why doesn't the main function run when I start a Python script? Where does the script start running?
Short answer. It's boilerplate code that protects users from accidentally invoking the script when they didn't intend to. Here are some common problems when the guard is omitted from a script. If you import the guardless script in another script, for example import my underscore script underscore without underscore a underscore name underscore eq underscore main underscore guard, then the latter script will trigger the former to run at import time and using the second script's command line arguments. This is almost always a mistake. If you have a custom class in the guardless script and save it to a pickle file, then unpickling it in another script will trigger an import of the guardless script, with the same problems outlined in the previous bullet. Long answer. To better understand why and how this matters, we need to take a step back to understand how Python initializes scripts and how this interacts with its module import mechanism. Whenever the Python interpreter reads a source file, it does two things. It sets a few special variables like underscore name underscore, and then it executes all of the code found in the file. Let's see how this works and how it relates to your question about the underscore name underscore checks we always see in Python scripts. Code sample. Let's use a slightly different code sample to explore how imports and scripts work. Suppose the following is in a file called foo.py. Special variables. When the Python interpreter reads a source file, it first defines a few special variables. In this case, we care about the underscore name underscore variable. When your module is the main program. If you are running your module, the source file, as the main program, for example, the interpreter will assign the hard-coded string underscore main underscore to the underscore name underscore variable, i.e. when your module is imported by another. On the other hand, suppose some other module is the main program and it imports your module. This means there's a statement like this in the main program, or in some other module the main program imports. The interpreter will search for your foo.py file, along with searching for a few other variants, and prior to executing that module, it will assign the name foo from the import statement to the underscore name underscore variable, i.e. executing the module's code. After the special variables are set up, the interpreter executes all the code in the module, one statement at a time. You may want to open another window on the side with the code sample so you can follow along with this explanation. Always. It prints the string before import, without quotes. It loads the math module and assigns it to a variable called math. This is equivalent to replacing import math with the following. Note that underscore import underscore is a low-level function in Python that takes a string and triggers the actual import. It prints the string before function underscore a. It executes the def block, creating a function object, then assigning that function object to a variable called function underscore a. It prints the string before function underscore b. It executes the second def block, creating another function object, then assigning it to a variable called function underscore b. It prints the string before underscore name underscore guard. Only when your module is the main program. If your module is the main program, then it will see that underscore name underscore was indeed set to underscore main underscore, and it calls the two functions, printing the strings, function A, and function B10.0. Only when your module is imported by another. Instead, if your module is not the main program but was imported by another one, then underscore name underscore will be foo, not underscore main underscore, and it'll skip the body of the if statement. Always. It will print the string, after underscore name underscore guard, in both situations. Summary. In summary, here's what'd be printed in the two cases. Why does it work this way? You might naturally wonder why anybody would want this. Well, sometimes you want to write a .py file that can be both used by other programs and or modules as a module, and can also be run as the main program itself. Examples. Your module is a library, but you want to have a script mode where it runs some unit tests or a demo. Your module is only used as a main program, but it has some unit tests, and the testing framework works by importing .py files like your script and running special test functions. You don't want it to try running the script just because it's importing the module. Your module is mostly used as a main program, but it also provides a programmer-friendly API for advanced users. Beyond those examples, it's elegant that running a script in Python is just setting up a few magic variables and importing the script. Running the script is a side effect of importing the script's module. Food for thought. Question: can I have multiple underscore name underscore checking blocks? Answer: it's strange to do so, but the language won't stop you. Suppose the following is in foo2.py. What happens if you say python foo2.py on the command line? Why? Now, figure out what will happen if you remove the underscore name underscore check in foo3.py. What will this do when used as a script? When imported as a module?
When your script is run by passing it as a command to the Python interpreter. All of the code that is at indentation level 0 gets executed. Functions and classes that are defined are, well, defined, but none of their code gets run. Unlike other languages, there's no main function that gets run automatically. The main function is implicitly all the code at the top level. In this case, the top level code is an if block. Underscore name underscore is a built-in variable which evaluates to the name of the current module. However, if a module is being run directly, as in myscript.py above, then underscore name underscore instead is set to the string underscore main underscore. Thus, you can test whether your script is being run directly or being imported by something else by testing. If your script is being imported into another module, its various function and class definitions will be imported and its top-level code will be executed, but the code in the then body of the if clause above won't get run as the condition is not met. As a basic example, consider the following two scripts. Now, if you invoke the interpreter as, the output will be if you run 2.py instead, you get thus, the module 1 gets loaded, its underscore name underscore equals 1 instead of underscore main underscore.
Create the following two files. Now run each file individually. Running Python at .py. When a .py is executed, it imports the module B. This causes all the code inside B to run. Python sets globals _name_ in the B module to the module's name, B. Running Python b.py. When only the file b.py is executed, Python sets globals _name_ in this file to _main_. Therefore, the if statement evaluates to true this time.
What does the if _name_equals_main_ do? To outline the basics. The global variable, _name_ in the module that is the entry point to your program, is _main_. Otherwise, it's the name you import the module by. So, code under the if block will only run if the module is the entry point to your program. It allows the code in the module to be importable by other modules, without executing the code block beneath on import. Why do we need this? Developing and testing your code. Say you're writing a Python script designed to be used as a module. You could test the module by adding this call of the function to the bottom, and running it, on a command prompt, with something like the problem. However, if you want to import the module to another script, on import, the do_important function would be called, so you'd probably comment out your function call, do_important, at the bottom. And then you'll have to remember whether or not you've commented out your test function call. And this extra complexity would mean you're likely to forget, making your development process more troublesome. A better way. The _name_ variable points to the namespace wherever the Python interpreter happens to be at the moment. Inside an imported module, it's the name of that module. But inside the primary module, or an interactive Python session, i.e. the interpreter's read, eval, print loop, or REPL, you are running everything from its _main_. So if you check before executing, with the above, your code will only execute when you're running it as the primary module, or intentionally call it from another script. An even better way. There's a Pythonic way to improve on this, though. What if we want to run this business process from outside the module? If we put the code we want to exercise as we develop and test in a function like this and then do our check for _main_ immediately after, we now have a final function for the end of our module that will run if we run the module as the primary module. It will allow the module and its functions and classes to be imported into other scripts without running the main function, and will also allow the module, and its functions and classes, to be called when running from a different _main module, i.e. This idiom can also be found in the Python documentation in an explanation of the _main module. That text states: this module represents the, otherwise anonymous, scope in which the interpreter's main program executes. Commands read either from standard input, from a script file, or from an interactive prompt. It is this environment in which the idiomatic conditional script stanza causes a script to run.
If you want to see more, please consider subscribing.